Determine the domain for the following function. We know that the domain is the set of all the valid inputs, or we can say all the inputs such that the function makes sense. So to solve this question, we will take a look at the expressions in the function, and then we will list all the conditions such that the function makes sense. And then we will solve those conditions to find a solution set, which will be the domain. We see the function f of x is made of the square root function and a fraction. And we know whatever underneath the square root has to be non-negative. So our first condition is going to be x squared minus 2x minus 3 greater than or equal to 0 to ensure that this is non-negative. And then for the fraction, it's obvious that the denominator cannot be 0. So we will have x minus 5 to be non-zero. Let's solve each of them. For the first one, we will use factorization to deal with this quadratic expression. It's going to be factored as x plus 1 and x minus 3. If you're wondering how we can come up with this combination, here is the fast recap. We will think of the constant term here as a product of two numbers, and then we find all the possible combinations. So possible combination to make this is going to be negative 1 times 3 or 1 times negative 3. But if we use the first combination, we see negative 1 plus 3 is positive 2, which does not give you this one. So that tells you this is the wrong combination. And then we test the second combination, 1 plus negative 3. That gives you exactly negative 2. So this is correct combination, which is used here. Okay, let's come back to solving this one. This is an inequality of a quadratic form. One of the easiest way to solve it is to just give a rough sketch of the quadratic expression. So we need to find the roots for it first. The roots, we can just spot it in the expression. That is x equal to negative 1 and x equal to 3. Because they are the numbers that make this expression 0. And after we have the root, we will place them on the number line. This is negative 1 and this is 3, right? We know this is a parabola that has leading coefficient positive, so its opening is going to be facing upward. So there is a parabola facing upward passing through these two roots. It's very easy to imagine what it looks like. It's going to be like this, which is the rough sketch of the function. Okay, so after we grab this function, we see on the interval from 3 to infinity, the curve is always above the x-axis, which indicates that the function is going to have positive value. And then on the interval from negative 1 to 3, we see the curve is below the x-axis, which tells us that the function has negative value. And at last, on this interval from negative infinity to negative 1, this is above x-axis, so it has positive sign for the function. And after we have this analysis, let's come back to the inequality. In the inequality, we are looking for all the x's such that this expression, function value, is positive. So that's going to be obvious, right? We're going to take all those x's after 3 and before negative 1. So that is going to give us the solution, which is x greater than equal to 3 or x less than equal to negative 1. And that is the first condition. The second condition is very easy to solve. is just simply x not equal to 5. Because these two conditions have to be satisfied in the same time. So both of them have to be taken into consideration when we determine the domain. So let's draw a number line and consider both these conditions. We have -1 and 3, right? X greater than 3 tells us that we need to go this way. And then x less than -1 tells us that we need to go this way. And the equal sign here indicates that 3 is included and -1 is also included. So that is kind of the diagram for the first condition. The second condition is x is not equal to 5. So the number 5 here has to be removed. And that's going to modify our graph a little bit. So we're going to have the graph that looks like this. 3 to 5, not including 5. And then from 5 to infinity. Okay, so let's put this into the final answer. So the domain is going to be from -infinity to -1, including -1, which indicates by this square bracket. And then we have our second interval from 3 to 5, including 5, excluding 5. At last, we have from 5 to positive infinity, excluding 5. And because these three intervals are disjoint, we will use the notation, which is the union notation, to connect them. So the final answer is going to be like this.